You all know that a force is required to move or stop any moving object. However, it is also seen that a fruit attached to a tree falls down without application of any force. During rainy season, the raindrops fall straight on the surface of the earth. Very large amount of energy is required by the rocket to go far away from the earth, but while coming back towards the surface of the earth, it requires very less energy. Which force is responsible for all these phenomena? Let us prepare ourselves to examine which force of the earth pulls bodies towards itself. Gravitation. If we throw any object in the upward direction, it reaches a certain height and then falls downwards. Do you know the story of Sir Isaac Newton? Newton was sitting under a tree when an apple fell on him. He started thinking that if the apple is attracted towards the earth, why cannot it get attracted towards the moon? Is the force same in both the cases? Sir Isaac Newton observed that all bodies are attracted by the earth towards its center by some force which he named as gravitational force. Newton generalized this idea and stated that not only the earth but every particle in the universe attracts every other particle. He argued that moon rotates around the earth in a circular orbit, but we do not really see the moon falling towards the earth. Instead, it moves in a straight line. This straight line is the tangent to the circular path. The centripetal force is center-seeking, or the force which is acting towards the center. The motion of the moon around the earth is due to the centripetal force. In absence of such force, the moon would undergo uniform straight-line motion. In our solar system, all planets revolve around the sun. There exists a force between the sun and the planets. If Earth attracts an apple, then can an apple attract Earth? Yes, it can, but the mass of an apple is negligible as compared to the mass of the Earth. Here, we do not see the Earth moving towards the apple. In the same way, Earth does not move towards the moon. Newton concluded that there is a force of attraction between all the objects in the universe. This force of attraction is called as gravitational force. Universal Law of Gravitation or Newton's Law of Gravitation. According to the Universal Law of Gravitation, every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Consider two bodies of masses m1 and m2 lying at a distance r apart. Then, according to Newton's law of gravitation, the force of attraction between them is given by F is directly proportional to m1 m2. Therefore, F is directly proportional to 1 divided by r square. On combining both equations, we get F is directly proportional to m1 m2 divided by r squared. Therefore, F is equal to g multiplied by m1 m2 divided by r squared, where g is the constant of proportionality and is known as universal constant of gravitation. If we put m1 is equal to m2 is equal to 1 and r is equal to 1, then we have F is equal to g multiplied by 1 multiplied by 1 divided by 1 squared. Therefore, F is equal to g, or g is equal to F. Therefore, the universal constant of gravitation is the force of attraction between two unit masses placed at unit distance apart from each other. The value of g does not depend upon the nature and size of the bodies. It also does not depend on the nature of the medium between the two bodies. Hence, it is called the universal constant of gravitation. G is equal to F multiplied by R squared divided by M1 multiplied by M2. SI unit of G is equal to Newton multiplied by meter squared divided by kilogram multiplied by kilogram, or Newton multiplied by meter squared divided by kilogram squared, or Newton multiplied by meter squared multiplied by kilogram raised to the power of -2. The value of G. The value of G in SI system is experimentally found to be 6.67 multiplied by 10 raised to the power of -11 Newton meter squared multiplied by kilogram raised to the power of -2. And in the CGS system, it is 6.67 multiplied by 10 raised to the power of -8 centimeter squared multiplied by gram raised to the power of -2. Following is the importance of the Universal Law of Gravitation. The Universal Law of Gravitation successfully explains 1. The force that binds us to the Earth. 2. The motion of the Moon around the Earth. 3. The motion of the planets around the Sun. 4. The tides of the sea due to the Moon and the Sun.